Good, so this is another question relating to specific heat capacity and also your latent heat. We're dealing with ice and water. So the table below gives data for water and ice. We have the specific heat capacity of water and the specific latent heat of fusion of ice. So we have a beaker contains 450 grams or 0.45 kilograms. Remember, we always work with kilograms at a temperature of 24 degrees Celsius. The thermal heat capacity of the beaker is negligible and no heat is gained or lost to the atmosphere. So basically we're saying that everything is taking place within the water and the ice. Calculate the mass of ice initially at 0 degrees Celsius that must be mixed with the water so that the final temperature of the contents is 8 degrees Celsius. So we've got this is basically going to happen. You're going to have your water on the water side. This is 8 degrees Celsius and this is at 24 degrees Celsius, and the water is going to drop down minus 24 degrees Celsius. So it's going to give out energy. It's going to give out energy in the form of 0.45 times the specific heat capacity of water, which is 4.2 times 10 to the 3 kilojoules times that times 24. That energy is going to be lost. Now, where does that energy it's gained? It's gained by the ice. Now, the ice, which has got a certain mass, which we don't know, but it's the ice firstly has to be melted. So that is going to be the mass of the ice times 330 times 10 to the 3. That will be the melting of the ice, plus, I should have given myself some more room here, plus the mass times the specific heat capacity of water, which is 4.2 times 10 to the 3 times 8, because the ice is starting off at 0 degrees Celsius and it will go to 8. So that ice which becomes water will actually increase 8 degrees in that way. And that will equal. So I can take the factor of this. I can factorize your mass out and I get 330 times 10 to the 3 plus 4.2 times 10 to the 3 times by 8 is equal to this value over here, 0.45 times 4.2 times 10 to the 3 times 24. And obviously I'm just going to take this value over here, I'll put it into green, and I'm going to put it under there and I'll divide it by that value and I'll get my mass. So we can work it out then. Let's just put it all into our calculator. We're going to need some brackets when we do it on our calculator here. So I open up my brackets and I do this over here. I put brackets around here and I put that in. So that's 0.45 times by 4.2 exponent 3 times by 24. Then I close brackets, then I divide and I open another set of brackets and I divide it by all of this over here. So that's 330 exponent 3 plus, we don't need to put this in brackets because the calculator is able to handle this, 3 times by 8, and I close my brackets, I just put enter and I get 0.125 kilograms. Now notice all my values are given with two significant figures, so I can write this as 0.13. Actually it's 1247, so it would be best to write this as 0.12 kilograms would be fine, like that. Okay, so again, it's really important here to draw a diagram to really understand the problem. You've got your ice, you've got your water, you've got the change in the water that's giving out the energy. You get the increase, the energy is being used to change firstly the ice, to melt the ice, and then to increase it 8 degrees, then setting it up in your equations. The final algebra and so forth is pretty straightforward. Okay, thank you very much.